Hello students, how are you? I hope you all are fine in this pandemic. Now let us start today's lecture of sets and relations of class 11s. Now let us say me, in my last sessions lecture we have discussed about sets. Today we continue with relations. Please students, let me say what do you mean by relations. The relation is, suppose in a family the relations between father and son, the relations between mother and daughter, these are called relations. Suppose A be a set and a relation E from A to B is from A to B is relation is a subset or equal to A cross B. Now let us discuss what do you mean by A cross B. Suppose A is a set. Suppose A is a set of alphabets A, B, C, D, E, F, etc. And B be a set of natural numbers 1, 2, 3, 4, all these are set. Then now consider what do you mean by A cross B. A cross B is can written as A1, A2, A3 in this way, and B1. This is a set, infinite set B2, because the natural number set is infinite set. Then when we write this in this way, for D also we write like this, for C, then next for D. In this way we continue. This is an infinite set. Then if I say R be a relations from A to B in such a way that the alphabet 1 is related with the natural number 1. The alphabet B is related with the natural number 2. Because if we serially say A, B, C, D, E, F, then how many alphabets in a English alphabets? There are 26 alphabets. Then the 1 is, then R is a relations from A to B in such a way that the alphabets are related to the natural numbers. A related to 1, B related to 2, C related to 3. In this way, D related to 4. In this way, if I say Z related to 26, this is a finite set. Then here look at here. This is R and this is A cross B. Then you find that the R is here subset of A cross B. Relations R is a relations from A to B in such a way that there should be built a relations between the set A and set B. Now let us discuss more about this. Now take some examples and discuss about this. Take an examples. Here we say that A be a set A, B, C, D, and B be a set P, Q, R, S. Then which of these following are the relations from A to B? As for your answers, please look at here. Suppose I say R1 is a set AP, BR, CQ, CS. Then another, then here R1 is, then R2 is a relations, is a set in QB and CS and DR. Look at here. Here R1 is A, P, B, R and C, S. Means here this is a R1 is subset of A cross B, because all elements of R1 A, P, B, R, C, S, R belongs to A cross B. A cross B means the elements which belongs to A cross B means the first components belongs to A and the second components belongs to B. Here in case of R1, look at here A, P. Here A belongs to set A and P belongs to set B, and in this B belongs to set A and R belongs to set B, and here C belongs to set A where the S belongs to set B. This means R1 is a subset of A cross B. Yes, R1 is a relations. Let us analyze the R2. Here R2 QB. Is Q an elements of A? Is Q an elements of A? No, because Q doesn't belongs to set A. And B here doesn't belongs to set B. Then this means Q and B doesn't belongs to A cross B. This shows that R2 is not a subset of A cross B. This means R1 is not a relations. Now let us think about R3. Here R3 says that R3 is equal to AP, AQ and DP and CR and BR. Look at here. Here R3, in case of R3, AP belongs to R3. Each AP belongs to A cross B. Each AP belongs to A cross B? Yes, because A cross B, I have already told you, A cross B is a set in such a way that the first components belongs to set A where the second components belongs to set B. Here A belongs to set A where P belongs to set B. In this case also AQ, here A belongs to set A and Q belongs to set B. In this DP, here D belongs to set A and P belongs to set B. CR, here C belongs to set A and R belongs to set B. BR, here B belongs to set A and R belongs to set B. This means R3. This means R3 is a subset of A cross B. This shows that R3 is also a relations between A to B. Now let us discuss about R4. What is the R4 says? I have already told you, when you practice variety of questions, you get a better idea about the theory. Then you get a profound knowledge about the theory. Look at here. Here R4 says that AP and QA, then QA and BS and SB. Look at here. Here AP, is AP belongs to A cross B? Is AP belongs to A cross B? When we say AP belongs to A cross B? When A belongs to A and P belongs to B. Look at here. Is A an element of A? Yes, A is an element of A. Is P an element of B? Yes, P is an element of B. Then look at the second element. Here the Q and A. Here Q and A belongs to R4. Is Q and A an element of A cross B? When we say QA belongs to A cross B? When Q belongs to A and A belongs to B. Is Q an element of A? No, Q is not an element of A. Is A an element of B? No, A is also not an element of B. This shows that QA doesn't belongs to A cross B. This means R4 is not a subset of A cross B. From these discussions, we come to the conclusion that R1 and R3 are the relations, where R2 and R4 are not the relations, because R4 is not a R4 and R2 is not a subset of A cross B, but R1 and R1 and R3 are subset of A cross B. Then if A is this set and B is this set, then here R1 and R3 are the relations between A and B, where R2 and R4 doesn't build up any relations between A and B. Then now let us discuss some theory. Now here says that suppose total number of relations, suppose look at here A and B are two non-empty finite sets M and A, then if A has if A has M number of elements, A has M number of elements and B has N number of elements, then A cross B contains, how many number of elements? A cross B contains M to the power N number of elements, Now, representations of relations. How can we represent representation of a relations? Representations of a relations is set booster, is roster form and set builder form. What do you mean by roster form? Roster form and set builder form. The roster form is if I say A and B are related to there is a relations R between A and B in such a way that A square is equal to B, then we say that suppose A is a set, minus 2, minus 1, 0, 1, 2, and B is a set of elements 0, 1, 4, 9 and 10, and A is in the roster form we write that there is a relations R from A to B in such a way that A square is equal to B. Then we can write it in the form that suppose A square is equal to B. This means 0 is related to 0 because here 0 square is equal to 0. Then minus 2 is related with 4. Minus 2 square is equal to 4. In this way, minus 1 is related to 1. 1 also related to 1, then 2 related to 4. These are the representations of the set in roster form. Then in the set builder form we can write in this way that in the set builder form we can write this is the representation of roster form, and in the set builder form set builder form, we can represent this set in the set builder form in such a way that the R is the relations in A and B from A to B is such that A belongs to A and B belongs to B such that A square is equal to B in such a way that A square is equal to B. This is the representations of set builder form, and in my last page I have discussed about rooster form. Now take some examples, and now let us discuss about the arrow diagrams. This is rooster form, this is set builder form, this is representations of arrow diagram, representations of arrow diagram, representation of relation in arrow diagram form, in arrow diagram form. Suppose A is a set, here the set A and here the set B. Then in the set A there are the elements are -2, -1, 0, 1, 2, and in the B set, in the B set the elements are 0, 1, 4, 9, 10. Here the A square is equal to B, means 0 is related to 0, -2 is related to 4, +2 is also related to 4, -1 related to 1, and 1 is also related to 1. This is R is the relations between A to B in such a way that A square is equal to B. Then this is the arrow representations, arrow diagram representations of the relations R. This is the set builder form, and in my last page we have discussed about rooster form. Now take some examples for the, look at here. Now take another examples. Suppose I say, then take another examples. Suppose I say A is a number 1, 3, 5, 7, 9, and B is a number 2, 6, 10, 14, 18. Then R is a relations from A to B. Then R is a relations from A to B in such a way that A is equal to B is equal to 2A. R is a relations from A to B in such a way that B is equal to 2A. Then the R is the relations from A cross B in such a way that A belongs to A and B belongs to B such that B is equal to 2A. Then in the rooster form we can write that 1, 2, 3, 6, then 5 related to 10, 7 related to 14, and 9 related to 18. Then in the arrow diagram form we can write, suppose this is set A, this is set B. Here 1, 3, 5, 7, 9, and here the elements are 2, 6, 10, 14, and 18. Here 1 related to 2, 3 related to 6, 5 related to 10, 7 to 14, and 9 to 18. Here R is the relations from A to B in such a way that B is equal to 2A. Now let us discuss what do we mean by domain and range of a relations. Then now let us discuss about domain and range of a relations. What is the domain and range? Domain and range of a relations. Range of a relations. What do you mean by domain and range of a relations? Please students note down the important factors. Important points. Let R be a relations from A to B, then the set of all past components of the coordinates of order pair is called domain. Then if R be a relations, if R be a relation from A to B in such a manner that A belongs to A and B belongs to B, then the representations of, then the domain means, suppose I represents A, B, here A belongs to A, then all A is called domain of the relation R, where B is called range of the relation R. Suppose take an example here, an example. If A is equal to 1, 3, 5, 7 and B is a set with element 2, 4, 6, 8, 10, then let R be a relations is where 1, 8, 3, 6, 5, 2, 1, 4 be a relations from A to B. Be a relation from A to B. Then here we say range of R is equal to the range of R is equal to 8, 6, 2, 8, 6, 2, 4 are the range, where domain is, which are domain 1, 3, 1, 3, 5, 1 are called domain. 1, 3, 5 are called domain of the relations, where 8, 6, 2, 4 are called range of the relations. Domain and range of a relations is said if R be a relations from A to B, where A belongs to A and B belongs to B, then A is called domain of the relations, where B is called range of the relations. Take some more examples. Then now let us discuss some more examples for better understandings. Suppose here take another examples. That suppose R be a relations from A to B. Suppose R be a relation. Students, please be attentive and follow my class regularly. I assure you to clear your all doubts and complete your syllabus. Please students, ask me your doubt in my comment box. I will solve your all doubts. 1, 2, 3, 4, 5, 4, 6, 8. Suppose B is this set, A is this set, and R be a relations, and where X related to R be a relations from A to B, where X belongs to A and Y belongs to B, in such a way that X divides Y. X divides Y. This means X divides Y means X is the x divides y means x is the factor of y. X is the factor of y. Then here the relations are is 2, then 2 related to 4, then 2 related to 6, because here 2 is also factor of 2, 2 is also factor of 4, 2 is also factor of 6. This is x divides y means x is the factor of y. 2 6, then 2 8, then next 4 related to 4 because 4 divides 4, and 4 related to 8. 4 is also related to 8. Then this is the relations from A to B in such a way that x divides y. This means x is the factor of y. In this case, domain of R is equal to 2, 4, where range of R is equal to 2, 4, 6, 8. These are range and this is domain. Now I think students you can understand what is domain and what is range. What is domain of a relations, what is range of a relations. Then the relations of a set A, B and non-void sets means if A is a set, is not a null set. Suppose A, B, A, then the relations on set. Relation on a set. Relations on a set. Suppose here A, B, let A be a set, not a null set, not a null set. This is not a null set, means A contains some elements, not a null sets. Then a relations from A to itself, then a relation from set A to itself, from set A to itself from this means A is a, this means a subset A cross A is called a relation on sets. Means a subset A cross A is a subset of is a relation from set A to itself, from set A to itself, from set A to itself. Then what do you mean by inverse of a relations? What do you mean by inverse of a relations? Inverse, this is the relations on a set if A be a set which is not a null set, means some elements belongs to set A. Then R is a relations from A set to itself. This means a subset, this is a subset of A cross A relations from A to set itself. What do you mean by inverse of a relations? Suppose A, B belongs to R, where R is a relations from A to B in such a way that A belongs to A and B belongs to B. Then the R inverse is a relations from B to A. This means if A, B belongs to R means B, A belongs to R inverse, belongs to R inverse. This means domain of R, this means domain of R is equal to range of R inverse, and range of R is equal to is equal to domain of R inverse. Now take some examples for better understandings. What is the meaning of range and domain? What is the relations between inverse of a relations? What is the, suppose A be a set, of natural number 1, 2, 3, 4, and B be a set which contains the 1, 4, 9, 16. Then here suppose R be a relations from A to B. This means here B is equal to A square. Here the R is a relations from A to B such that B is equal to A square. Here R is equal to 1 and 1 and 2 related to 4, then 3 related to 9 and 4 related to 16. This is the relations from R is a relations from A to B where B is equal to A square. In this case, inverse of R means this is a relations from B to A such that the element which belongs to A is square root of this. This means here is also B is equal to A square where B belongs to B and A belongs to A. Here B belongs to B and A belongs to A. But the relation is B is equal to A square. If I say, then this is equal to 1 related to 1 and here 4 related to 2. Here 4 related to 2 and 9 related to 3 and 16 related to 4. Then this is here this is square of this means inverse. Here R inverse is from B to A in this way. Here look at here. The domain of R is equal to 1, 2, 3, 4. 1, 2, 3, 4 which is equal to range of R inverse. Here domain of R is equal to range of R inverse. Then range of R. Here the range of R. What is the range of R? Range of R is equal to 1, 4, 9, 16. Is 1, 4, 9, 16 which is equal to domain of R inverse. Understand? Now let us discuss some more examples. Here another example says, suppose xy belongs to R is a relations such that x plus 2y is equal to 10. Here x plus 2y is equal to 10. This shows that y is equal to 10 minus x upon 2. 10 minus x upon 2 where x and y, here x and y belongs to A, where A is the set which contains the elements. A is the set which contains 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Then here R is the relations from A to A itself from A to A itself is here x plus 2y is equal to 10. This means y is equal to 10 minus x upon 2. Then if I take x equal to 1, then this is when we take x equal to 1, then y is equal to 9 by 2, which is not an element of A. Then this is not possible. When we take x equal to 2, then here y is equal to 10 minus 2 upon 2, which equal to 4. This means we cannot find the, when x is an odd number, then we cannot find the value of y which belongs to A. If I take x equal to 3, then this is 7 by 2. Is 7 by 2 belongs to this? No. Then for odd number we cannot find, but when x equal to 2, then y equal to 4. When x equal to 4, then y equal to 10 minus 4 upon 2, means 6 upon 2 equal to 3. Then when x equal to 6, then here when x equal to 6, y equal to 10 minus 6, 4 by 2, which is equal to 2. When x equal to 8, then y is equal to 10 minus 8 upon 2, 2 by 2 is equal to 1. Then here the R is a relation from A to A such that this is 2, 4, 4, 3, 6, 2 and 8, 1. This is the set R. Then here R inverse is a relation from A to A. From A to A, this is the inverse relations. This means here the domain of R, here the domain of R is equal to 2, 4, 6, 8, which is equal to range of R dash. Range of R, because R inverse is a relations from A to A. This is inverse relations, where here the A to A means the relations A to A. This is here y x plus 2y is equal to 10. Here y is equal to 10 minus x upon 2. But inverse relation is just inverse, just opposite from A to A, such that domain of R is equal to range of R inverse, which is equal to range of R inverse, means or range of R 4, 3, 2, 1 is equal to domain of R inverse. Okay. Then students, thank you students. Today this much. In my next sessions we will